All right, so this is quite an interesting problem, and we are dealing with a conservation of energy problem. And so, of course, we are dealing with potential energy equals kinetic energy. And in this case, we are dealing with a spring constant, so we know potential energy is going to be elastic potential, 1/2 k x squared is going to be equal to kinetic energy, which is 1/2 m v squared. Right, and we're going to go ahead and plug in our numbers, and we're going to get our answer. So let me write it out here. 1/2 k is the spring constant. It is 80. X is, of course, our displacement. How far back we pulled the bow, that's our displacement of the bow. 0.5 squared is going to be equal to 1/2 m. M is the mass, 0.05. And then v squared. V squared, of course, is the answer that we are looking for. So 1/2 of 80 is going to be 40. And then 0.5 squared, that's 1/2 times 1/2, which is 1/4, right? Half of a half, 1/4. So 0.25 times that equals 1/2. I'm going to leave these unsimplified, and I'll show you why, because mathematically, it's going to be much simpler if we do it this way. All right, 40 times 0.25, that's a quarter of 40. Right? So times 0.25 is the same thing as 40 divided by 4, which is 10. So 10 is equal to 1/2 0.05 v squared. All right, now what we're going to do is we're going to simplify these. So 0.05, we're going to divide by both sides by that, 0.05. And what's 10 divided by 0.05, right? Well, 10 divided by 5 is 2, and 10 divided by 0.05, well, that's going to be a much larger number, right? Because we're dividing by a very small number, right? So we have to move the decimal point back, and we did this, so we moved it 2 places to the left, and we're going to have to move it back 2 places to the right. So 1, 2. Yep, let me fix that. 200. Sorry, that looks kind of weird. Okay, 200 is equal to 1/2 v squared. Now, 200 divided by half, that's the same thing as 200 times 2. 400 is equal to v squared. And square root of both sides, the correct answer here is going to be 20 equals v, 20 meters per second. So the correct answer here is going to be A. I think there are only really 2 hard parts of this problem. The first is to kind of figure this part out and then plug in the numbers. And then the math, I mean, those are the only 2 parts of the problem, I guess, but the math can be a little bit ugly as well, so it might take you a little bit of time. I would generally recommend you practice this type of math a little bit to really try and get faster at it for the MCAT. But anyway, the correct answer here is A, 20 meters per second.